Hi guys, this is Pete, N6QW, and this morning I want to demonstrate a little test bed receiver that I'm working on. Actually, it's a test bed transceiver, and I'm using the Si5351A Adafruit PLL board that has three outputs on it, which you can see right here. This is the display. I have the default set up right now, so when it powers up for 40 meters, and it's operating on lower sideband, even though this will say 899850 with a 9 megahertz crystal filter here. It's because I'm placing the LO above it and you get a sideband inversion. Little volume control, little audio amplifier here, basically dumping the antenna without any kind of front end into an SBL1 double balanced mixer. There's two bilateral stages here, amplifier stages, comprised of a 2N3904 and a 2N3906, and these are surface mount, so you can hardly see what's here. A couple of coils going into a homebrew filter. By the way, this is a test bed that I use for crystal filters. The product detector is another SBL1, and it gets dumped right into the audio amplifier. The Si5351 is capable of generating a tunable VFO frequency and a fixed frequency BFO. So I just wanted to see what this thing would do. There's a lot of experimental work taking place across the world with the Si5351, and I just was interested to see how this would work with this little test bed. So it's an SBL1 here, that's the receiver transmit mixer, goes into two bilateral IF amplifier stages, which is combination 2N3904, 3906, and you can look this up in EMRFD. I think it's figure 6111, and this is not something I invented, it came from Plessy. This is a GQRP 9 megahertz crystal filter. Another stage here, this is an SBL1, which is acting as a product detector balance modulator. Goes through a two-stage audio amplifier, which is an Si5351 driving an LM380, so plenty of oomph there. There's nothing on the front end other than an antenna tuner, so this thing is receiving all signals all over the world. Okay, and there's 40 meters, and it's on 7203. I did calibrate the crystal in here, so the frequencies are pretty accurate. So we'll just tune it here. It's tuning in 100 hertz increments. One thing I haven't solved is a ticking problem, although it's not as bad. You can hear it in the background. $72.30. There's some foreign broadcast, 7245. Again, there's nothing on the front end other than the antennas getting dumped right into the SBL1 receiver transmit mixer. The two bilateral stages here, another SBL1 product detector balance modulator audio amplifier stage, the Si5351 PLL, which is developing two frequencies, a tunable one. And by the way, the LO as such for this receiver transmit mixer is operating above 7 megahertz, so it's at 16 megahertz, and then dumps it down to it dumps it down so that you go through the 9 megahertz IF. And then the Si5351 is supplying the BFO frequencies, which are tunable, by the way. And I'm going to switch to the other sideband now. So how about that? No crystals. The BFO is now By the way, the BFO frequency normally used for lower sideband used for upper sideband, and the upper sideband BFO frequency is used for lower sideband because of the frequency inversion. Okay, we'll turn it back now. But it tells you here, BFO is 899850.
Hey, what's going on?
How's that sound? No RF amplifier stage antenna right into the mixer. This will also tune in 1 kilohertz increments. And I'm going to tune it down to the CW part of the band. See what's cooking down there. There's a contest on a couple days ago. Actually, you can make this tune in 10 hertz increments, but I've just nulled that out in the software. This is Pete N6QW using my testbed receiver transceiver board with the Si5351 acting as the LO and BFO. I'm driving the Adafruit board right here, which costs less than $8, with a Nano, an Arduino Nano. So not much there. And I did add the capability so that you can switch the sidebands. Boy, this is real quiet in comparison to yesterday. I guess the contest is over. Okay, we'll put it on the 1 kilohertz and swing it up to and there we are.
I think.
Kinda cool. This is N6QW working with the test bed, IF at 9 megahertz, Si5351 PLL, providing the LO and BFO signals. SBL1 receiver transmit mixer, SBL1 product detector balance modulator, audio amplifier stage, GQRP 9 megahertz crystal filter, the LO and BFO provided by the Si5351. Which tells me you can build a pretty simple transceiver using not many components and relying on some of the new technology that's available. So all I'd have to add here to make this a transceiver is the microphone amplifier. I would also put a RF amplifier stage and a transmit pre-driver stage, and you got a complete transceiver here with not many parts. So again, I'm kind of excited. This is N6QW, and we're going to end this video right now.